After a long day of bugging Mario and Luigi, Wario usually goes to the bar for a beer. The bartender knows that Wario prefers beer in a mug and always slides the mug across the counter to land perfectly against Wario's palm. The curious bartender knows that the mug is about 1 kilogram and that the coefficient of friction for the wooden countertop is 0.2. If he sends the mug down to Wario with a velocity of 3 meters per second, how long will it take for the mug to stop in Wario's hand? How far away will Wario have to sit in order for this to happen? To solve this problem, the first thing we want to do is draw a free body diagram. The normal force exerted by the counter on the mug, the force of gravity which cancels out the normal force, the force of friction by the counter, which is in the opposite direction of velocity.
Yahoo!
This problem accounts for both the x and y directions. Since we're interested in the sliding action of the mug against the frictional force of the countertop, we're going to focus on the x direction. Here we are accounting for the forces belonging to our x and y directions using the momentum principle. F net for the x direction equals the negative coefficient of friction times the normal force, which makes sense because the frictional force counteracts the mug sliding in the positive x direction. In the y direction, the normal force of the counter and the force of gravity cancel each other out in order to keep the mug upright on the counter. So what we can do is solve for the normal force by setting the second equation equal to 0, and seeing that the normal force equals mg if you add mg to both sides.
Okay!
To solve for the time delta t taken for the block to stop, we can now use the equation P equals mv to use what we were given in the problem. So now we see that delta mv in the x direction equals the negative coefficient of friction times mg times delta t. Isolating delta t, we can substitute our final velocity subtracted by our initial velocity all over the negative coefficient of friction times g on the right-hand side, and simplify it by writing initial velocity over the coefficient of friction times g. We plug in our knowns, initial velocity of 3 meters per second, coefficient of kinetic friction 0.2, and acceleration due to gravity 9.8. We do the math to find that delta t is 1.53 seconds, so it takes the mug this much time to stop in Wario's palm.
Oh no!
For the second part of the problem, because we know that our net force is constant, we can use the arithmetic average velocity to find displacement. Remember that velocity is the change in position over time, so what we do is set just that equal to the arithmetic average velocity, and we find that it is 1.5 meters per second. We then isolate our displacement delta x by multiplying both sides by delta t. Plug in our knowns 1.5 meters per second and 1.53 seconds to yield 2.3 meters. All in all, it takes 1.53 seconds for the mug of beer to travel 2.3 meters into Wario's palm across the wooden countertop. And thus, Wario would have to sit 2.3 meters away from the bartender for this to happen.